This is the review video for activity 4 in your packet on factoring, and then we've got some graphing of inequalities. So to start out here, I have a factoring for the difference of squares. We have this 9x squared minus 16 right here. We call this the difference of squares because we are subtracting two perfect squares. So 9x squared is a perfect square, 9 is a perfect square, x squared is a perfect square, the whole thing is a perfect square, and then 16 is also a perfect square. And we are subtracting in the middle, so we can apply this really quick trick right here. Okay, so we need two sets of parentheses here, and we are just going to fill them in. To figure out what goes in the front of each set of parentheses, it's going to be the exact same thing. The exact same thing is going to end up going in the end as well when we get to that part. But to start out, in the front of each set of parentheses, if we take our first term here, and we take the square root of the whole thing, the square root of 9 is 3, and the square root of x squared is x. So we've got 3x in the front of both of these. We're going to do the same thing to figure out what goes in the back half of each set of parentheses. We're going to do that with the 16. So square root of 16 is 4. Got a 4 here, a 4 here. And the last thing is to put the sign in between those. So this one we can make a plus, and this one we can make a minus. And we are done. Much quicker than doing a box and diamond. Next example, factoring using the greatest common factor. Anytime that you're factoring something that looks like this, a trinomial or anything bigger, even smaller than that, the first thing that you always want to do is look for a GCF or a greatest common factor. It's going to make factoring in the long run easier if you can factor something out to begin with. So when we look at this, we look at each of these terms and we see if we can factor something out of all of them. So if I look at the numbers, I've got a 2, a 12, and a 16. I know I can factor out a 2 from all of those. And then the variables, x cubed, x squared, x. I can factor out an x from each of those as well. So when I do that and I factor out the 2x, I'm going to end up with x squared plus 6x plus 8. Okay, not completely factored yet because this trinomial here can be factored as well. The 2x needs to stay with it. It is considered a factor of this. Okay, so I'm going to use guess and check to factor this trinomial here. I know I'm going to need two sets of parentheses. And in the front of the parentheses, in order to get an x squared in the beginning here, the only way I can do that is to multiply x times x. Okay, and then in the end, I'm looking for two numbers that multiply to get 8 and add to get 6. So I think that's going to be a 4 and a 2. And then the only way to achieve those is to have a plus and a plus. So now we are completely factored. Now looking at graphing inequalities, the first example that I have for you is y is less than negative x plus 5. The first half of any graphing inequalities problem is to graph the line correctly. The second half will be the shading. Okay, so here when we graph this line, you can just kind of substitute in an equal sign. So y equals negative x plus 5. And then you're just graphing this line, being careful to determine whether it should be dashed or solid. So here we have a y-intercept of 5. So 1, 2, 3, 4, 5. And then our slope is negative 1. So down 1 to the right 1. And just make small points so that we know where it should go. Okay, now before you actually draw in the line, you need to determine what kind of a line you need. Whenever you are dealing with a less than or a greater than, but not an equal to, meaning it doesn't include, then you are using a dashed line. Since we have a less than here, we're going to draw in a dashed line. First half of the problem done. Now we just need to figure out where we need to shade. You can use the old method, which will take longer, of testing a point. Some students prefer to test maybe 0, 0, put it in, see if it makes it true. If it's true, shade that way. If not, shade the other way. I actually prefer to just read the inequality and determine where I should shade. So if I'm talking about my y values in relation to this line right here, which is y equals negative x plus 5, y is less than. So I'm talking about all the y values that are less than, lower than this line, which means I'm going to be shading this way. And that's it. Okay, so next example, last example here in this video. Y is greater than or equal to 1/3 x minus 4. So same idea, same process as before. Be careful when you're drawing your line. Be careful when you're shading. So we're looking at y equals 1/3 x minus 4. We have a y-intercept of -4. So 1, 2, 3, 4. And then we have a slope of 1/3. So up 1 to the right, 3. Okay, so now we have a greater than or equal to. Because it includes that line, we can go ahead and draw in a solid line. So if you're a perfectionist, you can get some kind of straight edge out. If not, it's okay to give it a nice rough sketch. Now figuring out the shading. Again, I'm just going to read through my inequality to determine where I need to shade. Y is greater than or equal to. Mostly the greater than is what I'm looking at, greater than. So I'm looking at y values greater than this line right here. All those y values are going to be up here. So I am going to shade in that way. And that's it. That's all you have to do for these.